physics, materials, and latent heat. Correct. Great, we have 2 more to do to finish this chapter. Now, you're talking about chemistry labs. You'll have your physics labs pretty soon.
Do we have to do experiment?
Oh, yes.
We used to go DIT.
Oh, no. No
DIT.
No DIT. No. We'll do them. No, we'll do them. We'll do them here. Yeah, I have the equipment in the teacher's room.
Then we can do it in the class.
We'll do it in class.
Where the husband?
No. I thought of this. I made sure to pick experiments that won't cause any death or injury. No. Who does this?
Hello.
There's no coffee.
No, Starbucks.
No.
Here, go around this way.
No time.
No time. All right.
I want to go Starbucks.
Yeah.
Too cold. Later.
Later. Okay.
Late. Oh, late.
What happened? The bus?
Yes. Raining.
Is it?
Yeah.
I didn't notice.
Wow.
Okay. Homework we're looking at. How long will it take to bring 300 grams of ice to steam? Okay. Have you tried these, Grace?
Yes.
Okay. Have you got them?
Maybe. I tried. But I have no same number.
That's okay. Delta Q equals MC delta theta. The M is 300. What's the C, Harry? 4181, isn't it?
Yeah.
And the delta theta is 100.
What's this?
Huh?
What's this? It's not something for something.
For the first one?
Yeah.
Only this? Oh, no. I said I want steam, did I?
Yes.
No, because
Yes.
from ice.
It's already ice. Okay. So this is also needs a plus ml and a plus ml as well. Yes. And the this is for the vaporization and the fusion. Plus the other pieces. Hareen or Grace, do you have the constant for latent heat of fusion and latent heat of vaporization? I'll put them together. Save space.
Vaporization is 2265.
2265 kilo.
Another one is 54.
What is it?
334.
334 kilo. You got a big number?
I got a strange number.
A strange number? Why strange?
Maybe my calculator is wrong.
No, well I got 905 kilojoules. Power equals work over time. Time equals work over power. 905 kilojoules over 2 kilowatts. So I get 453 seconds.
Oh.
What?
I forgot to put 30 after 2265.
Shocking. Okay, is that okay? Students who didn't do their homework?
Ooh. Good monitor.
Yeah. You know why they didn't do their homework?
Yeah.
Yeah.
With Lisa.
Yeah, that's it. Girlfriends distracting them. This is the problem. All right.
No.
No. Oh, I thought you just made one small mistake. You don't need to write all of this, do you?
Because here is wrong, so I remove
Okay.
everything.
Continue?
Yes.
Right. How long would it take to bring ice at minus 100 to steam at 200 by using a 4 kilowatt kettle? The kettle is 90% efficient. So the first thing I'll do is get the power. Efficiency is power out over power in. So then power out is efficiency multiplied power in, which is 90, well, yeah, I should put it times 100, but if I put the percent in here, I don't need to. 90% of, what's power in, did I say? 4 kilowatts? Was it?
Yes.
4 kilowatts. So that would be 3.6 kilowatts. Yeah. What was the mistake?
Sorry.
Alright, so first it goes from minus 100 to 0. So that's M. What's the M here? 0.3. Now look, guys, listen, because the M is in everything, I'm just going to take it out to save time, because the M is in every part. So the first one is from minus 100 to 0. So that's C for ice, delta theta, 100. Then we have latent heat of fusion, and then the water becomes 100 hot. Heat capacity of water times 100. Then it becomes steam, and then the steam becomes hot as well. So it's a lot of things to add together, but it's the same idea. The cold ice becomes ice at 0. The ice at 0 becomes water at 0. The water at 0 becomes water at 100.
This part I'm right.
Yes.
But then this part is not. First, P out, P in.
What did you get?
I use 4.
Not 3.6. Yeah, well, that's okay. Right. So can you give me the first number is, what's the heat capacity of ice? It's about 2,000, isn't it? Yeah. 2110. Oh. And latent heat of fusion, well, I have it here. It was okay. And then and what's the heat capacity of steam? 2080. Right, so if you put all the numbers in, you get a very big number. Like this.
I can't see my whole.
Power is work over time. Time is work over power. 1600530 over 3600. This one here is the ice to go from minus 200. Wait, 200?
It's 300. 200 minus 100, that's 300.
No, you have to do it in steps. Minus 100 to 0, 0 to 100, 100 to 200.
So,
Yeah. 1, 2, 3, 4, 5 steps. How many steps did you have?
3.
Not enough. Okay, so this here is only 445 seconds. Well, I guess that's pretty long, because that's 7.4 minutes. Yeah?
Huh?
Yep. Okay, next.
No.
No. Where's Sohi?
Latent.
Really? I don't think so. That doesn't sound like Sohi.
I'll be on the bus.
Mm, maybe sleeping actually. Okay, continue. No. Alright. Hareen, what's the next question asking you to do?
How much energy?
How much energy? Oh, you have it, Grace. What is it?
How much energy is required to boil off 500 milliliters of water at a temperature of 20 degrees?
It's not too bad. I'm continuing now, Amanda. Yes? Okay. Right, so how much water do you have? 500 milliliters. Okay. So that is 0.5 kilograms and its temperature? 20 Celsius. So, is it how much energy?
Yeah.
So delta Q equals M C delta T plus M L. And Tareen, what's the constant? 2285?
No,
2265. 000. Alright. Is this what you did, Grace?
no,
Oh, what happened?
I don't know. Doing the homework makes me
Sick, huh? This is, oh, my pen, there, come back. This is 1.3 megajoules.
You don't need to multiply rho, V multiply rho equal M and then calculate.
Oh, but I know in my head that 500 milliliters is half a kilogram because 1 liter makes 1 kilogram of water and 1 liter is 1000 milliliters. No?
No.
Is that a hamburger? So we had a hot dog yesterday and a hamburger today. Okay.
yesterday I'm not hamburger, I'm just 2 pieces of bread.
But today you get a hamburger.
Yeah, I don't like hamburger, I like piece of bread.
You don't like hamburger? What's wrong with you?
Do you like this type of hamburger?
Yeah? Wait, what's on it?
Just meat.
Wait, just meat?
Yeah.
Just meat?
Ketchup.
Okay, good.
And nothing.
That's okay. Oh, life is so difficult.
Poor
Poor Grace, yes.
and no
Poor Grace must have a hamburger for breakfast. Alright. Continue, Amanda?
No.
No? What?
Confused.
About what?
Why is 0.5 kilogram?
Is that not the question?
I get 500 kilograms.
500 kilograms? But 500 milliliters is like a bottle of water.
It's not changed to MQ and then multiply the rho.
MQ?
Yeah.
MQ?
Because it's milliliter, so should change to
Yeah, so
MQ
500
ml.
milliliters. 500 milliliters. That's 500
Multiply
10 minus 3 liters.
And then multiply.
That's equal to, well, I suppose that's 5 times 10, 2 times 10 minus 3 liters, isn't it? 5 times 10 minus 1 liters, yeah?
Yeah, and then multiply.
Which is 0.5 liters.
Oh.
Yeah. So volume, this is what you mean, is it? Volume, density is mass over volume. So mass is density by volume. So remember that 1000 liters equals 1 meter cubed.
So change the unit.
Yeah, so this will be 0.5 over 1000 meters cubed. It's okay now?
Okay.
Right. Continue? Next, 4.
See, you have a calculation.
A 2 kilogram copper plate was heated to a temperature of 95. Ice was poured onto the copper to then cool it down. All the ice turned into steam and quickly left the copper, so it did not exceed 100. How much ice was required to cool the copper down so a person could hold it? Okay, so what you have here, you have some copper and it's at 95 Celsius, and then you pour some ice on it, and then the ice turns into steam, and the copper, it becomes 25 Celsius. Do you see? Yeah? So, what gains heat and what loses heat? So, what gains heat?
That one. Wait, I thought, the copper is not producing
So look,
the heat.
yeah, no, look. So you have the copper, and it's at 95 Celsius, and then you pour the ice on it
Why would you pour ice on
to
it?
cool it down. So like this is like a metalsmith or something. You know, you see them, they put ice in it or put in water. So this is 95 Celsius, they pour the ice on it, and it cools it to 25. So the ice gains energy, and the copper loses energy. Okay. Oh, come on. Alright. So the energy which is lost by the copper, that's equal to the energy which is gained by the ice. How much copper do we have? 2 kilograms. So M, what's for copper? .385 MC, and it's 70. Now the ice, I think I said is at 0. I hope I said it's at 0. I didn't. Okay, I'll tell you now the ice is at 0. I should have said that in the question. So what happens to the ice? The ice becomes water. The water becomes 100, and then it becomes steam. So there's a few steps here. So firstly, the ice, that's M, we don't know N, L. Then what happens when the ice becomes a liquid?
Becomes water. It's already water now, right?
No, now it becomes water. So now you have MC delta theta, which is 100. And then what happens to the water when it's at 100? It becomes steam, which is ML vaporization. So the ice, what?
Times temperature change. What did you? Oh wait, for one, why is that 3 0?
Times 100.
There are only 2 zeros.
Thank you. Two zeros. Okay, so you're looking for the mass of the ice, so you're looking for the M, so we can have M equals 70 over 418,100 plus. So what is the latent heat of fusion, Hareen? 385,000. And vaporization?
Wait, fusion is 334.
334,000, and vaporization? Or 2265,000. Right, so what do we got here? 2 times 385 times 70 over 334000 plus 418100 plus 2265000. So this is 0.0179 kilograms, or if you want, that's about,
0.02.
yeah, I was thinking more like about 17.9 grams of ice. In the exam, I think their favourite question is when you're mixing ice with water or something else and they want to know how much ice you needed. They like asking this one. Okay, continue? Yeah. Some ice is mixed with water in a kettle. The water and ice are brought into equilibrium. The mixture was heated up until all the ice and water turned into steam and left the kettle. The power rating was 3 kilowatts and the whole process took 5 minutes. How much water was in the kettle? Okay. How did you do with this one?
No idea.
Difficult, yeah? So what you have, your kettle, and you have some water and some ice in it. You don't know how much water you have, so we'll say m kilograms. But we know how much ice we have. How much? It's 50 grams, yeah? And what's the temperature here? 0 Celsius. Then what happens? 5 minutes later, it all becomes steam.
With that, the ice is 0 degrees Celsius. The whole thing is 0 degrees Celsius, right? Comes to water.
Everything's 0 at the beginning. Yeah? Now, what's the power of the kettle? What's the power?
Of what?
The electric kettle, what's the power? 3 kilowatts. And what's the time?
5 minutes.
So that's 300 seconds. And power is work over time. So then the work, which is the delta Q, would be 900,000 joules. That's how much energy there is in total. From going from the left to the right, 900,000. Does that make sense so far? What did this energy do? It changed the water into steam, and what else did it do? It changed the ice into steam also. So you have 900,000. Okay, so we'll do it in 2 parts. We'll do the water first. So the water then is MC delta theta plus ML. And what's the L for vaporization? It's 265. Yeah? Or 2245? 65. Great.
334.
Right. The other one's 334. Yes. 2265000. Then plus the ice, which is 0.05. That ice becomes liquid water, 334000. Then that gets warm by 100. And then plus the liquid water from the ice becomes steam, 0.05 226500. Okay, so now we can get the M easily. It's just lots of numbers to add together. I got 0.279 kilograms is the answer.
The ice,
Ice becomes water.
water.
Water becomes water at 100, and then that becomes steam.
So this power water, why is not plus another power water? They have water inside.
Yeah, that's it there. Look, this is the water at the start. This water becomes steam, and then this here in blue, this is the ice. And together they must be this much. Yeah? Okay now? Yeah. Maybe after the next question, if you're very quick, you can go buy coffee.
Okay.
Less than 5 minutes? 300 seconds.
If there are not many people online.
Yes. But if there are many people, you must turn around
Yeah.
and come back. Yes. Okay, next question. I'm too kind. This is my weakness. Right. Oh, come on. 6. Nitrogen boils at minus 195.79. The heat capacity of glass is 840. Nitrogen is at its boiling temperature, is poured into 50 gram glass at temperature 20. Latent heat of vaporization of nitrogen is that. How much nitrogen was required to bring the nitrogen glass into thermal equilibrium? Okay, so this is what's happening. I'll try and draw it. You have a glass. And the nitrogen is at minus, so it's poured in, and its temperature is minus 195.79 Celsius. And then it comes back out as a gas. But its temperature is still minus 195.79. You've seen liquid nitrogen on TV before, haven't you? Yeah. I think you do.
It goes in at negative 957, it goes out at negative 957.
Yeah, it's still the same temperature, but when it goes in, it's a liquid, and when it comes out, it's steam. It's a gas, yeah.
So what's the
Well, what's happening is the glass cup is at 20 Celsius. So it gains energy from the glass cup. Will the cup stay at 20? No. It will become what?
No.
Even colder. It will,
Minus
yeah,
195.
0.79.
Really?
Yeah. Well, if it doesn't break, but I mean, yeah, it will become this temperature after some time.
Wouldn't it break?
Probably.
Why is,
Well, think about it like this. If I have a lot of water at 100 Celsius and I pour it at Hareen, for example, eventually, if I pour enough water at him, he also will become 100 Celsius. I might need a lot of water though. Yeah. But no, if you think about the cup, okay, so if you pour in hot water, the cup gets hot. But if you keep pouring hot water at 100, eventually it will also become 100. Now you might need a lot of hot water, keep pouring, but after a while it also will become 100, because remember, the hot moves to the cold until they're balanced. Yeah. Yes? Okay, so who loses energy? The cup. So the energy lost by the glass, and what gains energy? The nitrogen gains energy. Get the idea? Right. What's the mass of the glass? What's the mass of the glass? 50, was it? And what's the heat capacity of glass? I said it in the question, maybe. 840. And what is the change in the temperature? It is a lot. 215.79. Dude, stop chatting on your phone. Put it away. Or are you going to use it for physics?
Yeah.
Now.
my fault.
No, I know. You're just a victim, yes. Right, so here, this is the energy lost by the glass. That must equal the energy gained by the nitrogen. Is the temperature of the nitrogen changing?
No.
No. The nitrogen? Is its temperature changing? No. So the only formula here is mL. Now what's the L for nitrogen, the vaporization? It's 25,700. So that means M is 0.353 kilograms.
Not that hard.
Not when I do it.
Yeah.
Okay, but this is the thing, in the exam, this, by the way, this was a section A question maybe 2 years ago. Yeah, now when you look at it, it looks easy, but when you're in the exam and you're looking at it, it won't. So this is why it's important to do the homework to practice. Okay, Hareen and Andy? Yeah. Okay, so 5 minutes. No, you don't want it?
After.
This will be better for you? Okay, well,
Because after class I have 2 hours
of what?
break.
How difficult.